SAE India is India's leading resource for mobility technology. As an individual member-driven society of mobility practitioners, the ownership of SAE India rests with its members who are individuals from the mobility community, which includes engineers, executives from industry, government officials, academics, and students. SAE India is a strategic alliance partner of SAE International, registered in India as an Indian non-profit engineering and scientific society dedicated to the advancement of the mobility industry in India. We are the most preferred technical body for knowledge dissemination and skill development of mobility professionals, students and faculty. We are a trusted think tank advising policymakers on mobility-related matters. We are a self-sustaining society with more than 10% of mobility professionals as members. We are a nimble and professional organization creating value for mobility engineering community. The Indian government is also actively promoting indigenization with cutting-edge technologies by manufacturing them in the country under Make in India and Atmanirbhar Bharat. SAE India is India's leading resource for mobility technology. As an individual member-driven society of mobility practitioners, the ownership of SAE India rests with its members who are individuals from the mobility community, which includes engineers, executives from industry, government officials, academics, and students. SAE India is a strategic alliance partner of SAE International, registered in India as an Indian non-profit engineering and scientific society dedicated to the advancement of the mobility industry in India. We are the most preferred technical body for knowledge dissemination and skill development of mobility professionals, students and faculty. We are a trusted think tank advising policymakers on mobility-related matters. We are a self-sustaining society with more than 10% of mobility professionals as members. We are a nimble and professional organization creating value for mobility engineering community. The Indian government is also actively promoting indigenization with cutting-edge technologies by manufacturing them in the country under Make in India and Atmanirbhar Bharat. SAE India is India's leading resource for mobility technology. As an individual member-driven society of mobility practitioners, the ownership of SAE India rests with its members who are individuals from the mobility community, which includes engineers, executives from industry, government officials, academics, and students. SAE India is a strategic alliance partner of SAE International, registered in India as an Indian non-profit engineering and scientific society dedicated to the advancement of the mobility industry in India. We are the most preferred technical body for knowledge dissemination and skill development of mobility professionals, students and faculty. We are a trusted think tank advising policymakers on mobility-related matters. We are a self-sustaining society with more than 10% of mobility professionals as members. We are a nimble and professional organization creating value for mobility engineering community. The Indian government is also actively promoting indigenization with cutting-edge technologies by manufacturing them in the country under Make in India and Atmanirbhar Bharat.
Session will start at 3:30. So
SAE India is India's leading resource for mobility technology. As an individual member-driven society of mobility practitioners, the ownership of SAE India rests with its members who are individuals from the mobility community, which includes engineers, executives from industry, government officials, academics, and students. SAE India is a strategic alliance partner of SAE International, registered in India as an Indian non-profit engineering and scientific society dedicated to the advancement of the mobility industry in India. We are the most preferred technical body for knowledge dissemination and skill development of mobility professionals, students and faculty. We are a trusted think tank advising policymakers on mobility-related matters. We are a self-sustaining society with more than 10% of mobility professionals as members. We are a nimble and professional organization creating value for mobility engineering community. The Indian government is also actively promoting indigenization with cutting-edge technologies by manufacturing them in the country under Make in India and Atmanirbhar Bharat. SAE India is India's leading resource for mobility technology. As an individual member-driven society of mobility practitioners, the ownership of SAE India rests with its members who are individuals from the mobility community, which includes engineers, executives from industry, government officials, academics, and students. SAE India is a strategic alliance partner of SAE International, registered in India as an Indian non-profit engineering and scientific society dedicated to the advancement of the mobility industry in India. We are the most preferred technical body for knowledge dissemination and skill development of mobility professionals, students and faculty. We are a trusted think tank advising policymakers on mobility-related matters. We are a self-sustaining society with more than 10% of mobility professionals as members. We are a nimble and professional organization creating value for mobility engineering community. The Indian government is also actively promoting indigenization with cutting-edge technologies by manufacturing them in the country under Make in India and Atmanirbhar Bharat.
Hello, all. Good evening, everybody. Thank you for joining us on this yet another interesting webinar from SA India on electric vehicle NVH refinement approach. We are witnessing a rapid transformation from conventional ICE vehicles to battery electric vehicles which is catching rather a good pace rather than a astonishing pace that we are seeing right now. So to meet this fast-paced acceptance of electric vehicles in the market, sustainable and efficient solutions needs to be developed at a tempo higher than we ever expected. And one such crucial challenge or area is NVH, noise, vibration, and harshness. The propulsion system in electric vehicles tend to be much quieter compared to ICE vehicles, as we all know, as there's lesser moving parts and the motors quite silent than the conventional ICE engine. So NVH in electric vehicles tend to have a completely revamped scenario now. We have newly uncovered noises such as road, wind, and auxiliary noises, which were quite how to say, which was neglected well before, not much considered as the main NVH was into the engines and the moving parts. But now with EVs, the this area is more considered and worked upon, because the consumer expects luxury in in everything that they do right now, even for middle ranged consumer vehicle. The consumer expects the best in class, so each area has to be improved significantly to meet the customer demands. So that's why the working principle of electric motor produces high frequency tonal noise along with modulation signal noises emerging from power electronic components associated with the powertrain. So in this webinar, we will see how to tackle these challenges and the approaches and the tools that are needed or to be developed. So the crux of this webinar lies in presenting a holistic view of battery electric vehicles NVH refinement approach by FEV, a thorough discussion on long-term sustainable practices and tool chain for tackling the mentioned challenges, developed using FEV's extensive competency and experience in NVH refinement is presented. Also, simulation methodology in sync with NVH testing approaches, and finally, the technology drivers of today's NVH scenario in vehicles will be discussed, with advancements and directions adopted by market leaders and research organizations in the NVH domain. So, to give us a holistic view, today we have a well-respected and renowned speaker or industry expert today with us from FEV, Dr. Sachin Val. He has a collective engineering experience of 23 years in the industry. Currently, the director of vehicle and consulting at FEV India Private Limited. He has a diverse experience starting from ARI Pune in the NVH domain, powertrain vehicle, to Tata Motors in the passenger cars platform as a chief engineer, and then moving on to JSW as a head of vehicle engineering, and currently in FEV as director vehicle and consulting. He has worked in numerous interesting projects, starting in Tata Motors, leading the engineering delivery of entire vehicle program, achieving cost, quality, and set engineering target right from concept to production and aftermarket response as well. And in JSW, he has conceptualized the EV business and product portfolio with engineering leadership. His areas of expertise include complete vehicle development with engineering, vehicle development product lifecycle, product engineering, vehicle integration and attribute management, leadership, NVH development, project management, supply sourcing, and value and cost engineering. So with this rich experience and a diverse technological prowess, we welcome Dr. Sachin Wag today, and I hand over the session to him to start.
Yeah, thank you. First of all, AC, to provide us this opportunity to interact with the Indian fraternity of the NVH expertise. And this is an opportunity for us to showcase how the NVH development is happening for the electric vehicles. So thanks for the introduction as well. So time is very limited. NVH is a very vast topic. So I would like to quickly jump upon the presentation or the technical content of my presentation. So if you can see, please let me know my slides.
Yeah, yes, sir. Your screen is visible. So you can go to, yeah.
Yeah. So we as a FEV, our brand, it's a brand we are considering as a field evolution, and we as a FEV always take this as a complete mobility divergence or maybe convergence is happening all across the globe in the mobility domains, and that's why we are rebranding ourselves as a field evolution and ride the journey of next 2 to 3 decades in the mobility solutions. So this webinar will give you the idea or the maybe information about the NVH refinement approach for the electric vehicles. So this introduction already been done by SAE team. I'll skip this. So first you should understand that what is FEV and how we have been associated and what have been our footprint all across the globe. So we being an international or multinational engineering service provider for the global automotive industry. So we are present in more than 42. So we are having more than 42 subsidiaries and present in 50 different nations. Our biggest strength is that we are the technology driven organization, and that's how we file at least 200 patents every year. The biggest strength of FEV is that industry academia associations. So globally, most of the major universities and the technical colleges, engineering colleges, so we have our association so that the innovations and the culture of the research and development should be nurtured from the second year or third year of the engineering or maybe technology domains itself. Also, we are having more than 300 plus test cells present all across the globe. And out of that, 12 test benches are available in India. And our manpower, this number is very floating every fortnightly. This number is keep on increasing for as we are servicing and giving our services and offering for the global automotive market. Now coming to the domain, so how we have been placed for the NVH. So we are having 6 engineering centers all across the globe. So where headquarters in Aachen, Germany, then there is a US, Detroit, then there is one more center in southern Germany, the one is in Mexico, and then other one is Shanghai, and this red one highlighted is our FEV India's technical center. Because we are having comprehensive strategic alliance, so with our technical NVH resources across the globe, and we can talk about and we give the clinical or technical solutions and resources all across the globe from the program for the entire geographic of the world, where the challenges, requirements, and customer expectations are different. So we are having our NVH test facilities where we can cater ICE, internal combustion engine, and electric drive units, powertrain, vehicle evaluation at our Talegaon facility, which is very next to the ex-General Motor plants in the Talegaon MIDC. So how is the overview of the NVH? So though it's more of the FEV point of view, but as any NVH development point of view, it starts with the benchmarking. We do very comprehensive benchmarking with more than 700 to 800 parameter on the overall vehicle level being benchmarked. Subjective assessments, more than 100 parameters will be done, and it's very important aspect of the benchmarking being considered. Then we do the concept layout and target setting. The system selections, that is one of the part of it. We use the simulation, is a front loading tool for the NVH development. Then testing setups for the powertrain as well as at the vehicle level, entire powertrain integration on the vehicle. We do very customized tool development for the different NVH problems. So also in NVH, the troubleshooting is very important It's the problem is being pursued by 1% of the client or 2% of customers at the end customer, basically those who are the using the vehicles for them. So the troubleshooting is a very fast and war footing tool has to be established. So we support in that activity as well. Most important part comes design for sound quality. So sound designs and sound quality aspect. So the brand signatures creation is also important aspect. Interior noise quality as well as the component aggregate level development for NVH. There are 10 very critical aggregates which are significantly contributing in the overall NVH perception of the vehicle. Yeah, this is our facility, the anechoic chamber. These are the very unique and very specific facilities required for the noise measurements. Anechoic means eco-free. So the dimensions of the chambers is depending upon the cutoff frequency. Lower the cutoff frequency, higher will be the dimensions of the chambers. So we have to identify what should be the cutoff frequency, what kind of the object like powertrains or maybe any other NVH objects are going to be measured here. So 50 Hz is a very adequate cutoff frequency for the Indian automotive applications, basically. There are powertrains 225 kilowatt, then another 314 kilowatt dyno torques. So these are all basically the specifications where we can run the EDU as well as the IC engines. And we can have different permutation combinations in the same chamber where front wheel drive, rear wheel drive, all wheel drive or only transmission. So this is a very one of the state of the art facility where we can give the all permutation combinations as a powertrain is a significant NVH source in the vehicle. Okay. We recently also upgraded this chamber so that all sorts of EDUs or motors or transmissions, especially for electric vehicle, that can be addressed or measured into the anechoic chamber. So we put up the DC supply source which can act as a battery for to run the motor. That is now coming to the simulation side. It's again a multidisciplinary approach already in the simulation side, which is the multi-body dynamics, which is very much essential to understand forces of the all rotary or the road induced or then the mechanical excitations induced forces which are being generated and given to the body. So this multi-body dynamics when it happens, statistical energy analysis, this is typically high frequency analysis where this is also one of the simulation tool where we can have a, because high frequency contributes significantly into the overall noise level of the vehicle and that can have significant impact on the sound quality perception of the vehicle. Boundary element methods that can predict the noise inside the cabins. So this is an important tool. Computational fluid dynamics, that is the aero and the drag induced forces which are coming on the body and generating the wind noise. So this is also a very important tool. And then finite element analysis, which has been acting as a structural components which are contributing into the noise and vibration behavior of the vehicle. So this is the predictions can be used through the structure. So this all put together. So that comes on the vehicle. So this is the test trick and you can do this kind of testing in the simulation and the body can put upon this. So you can actually run in different operating conditions, how the body is responding with respect to different gear, different engine RPM, and given the real life characteristics of the all elements here. So this is CA approach in the evaluation. So how is the NVH? This is overall introduction part of it. So now coming NVH development methodology. So you must be aware that we as a customer, we all are customer at the end of the day. So which are anybody, the manufacturer will is manufacturing the vehicle. But when we go as a customer buying any specific vehicles, so we always look at these are the parameters. We are all our engineers and we understand these the terminologies like design and appearance, product performance, product efficiency. It comes under range or fuel economy, then connectivity, driving dynamics. So these are all attributes being defined. And where is the NVH? So NVH is here. So we have to always look at it, how we are positioning these attributes. It is uncompetitive or means it is not at all acceptable. This market is so dynamic. Already product life cycle has significantly reduced. So uncompetitive, any of the attribute we are out of the market. So these are the only three that is competitive amongst the leader and the leadership. So we have to always look at with respect to competition. which are the leadership positions we would like to take. And the general expectation and the perception of the vehicle has been defined by NVH. You can look at this operating sound quality, or when you take the ride and drive of the vehicle. So NVH comes into the picture. So every OEMs always trying to aim to give the leadership attribute as a NVH. And when we are talking at the leadership, the moment we say this attribute has to be leadership, then the way we select the subsystems and systems, so there will be a different target level, the system level targets has to be very stringent compared to if this NVH comes here or NVH comes into competitive. So that system selections always varies. So it is not only at the cost, but it is at the quality, it is at the life cycle. So everything has to be considered when we define the product attribute leadership strategy. And NVH always been, everybody tries to put up as a leadership position. In the project phases, there are four very important NVH development phase. The requirement phase, development phase, confirmation phase, and pre-series phase. Pre-SOP, post, just before the SOP. All phases are having equal importance, especially for NVH when we are doing the development bumper to bumper. Each and every aggregate, every component is playing into the noise and vibration signature of the vehicle. So the requirement what we are putting, that is also very important. If you select, give the right requirement, then you design the aggregates or parts with the right requirement. Your tier 1s or tier 2s are providing a part with these right requirements. Then real development starts. So where there will be a simulation tools being used, there will be a testing methodologies will be used. There are 2 to 3 types of different prototype services, the prototype builds will be done, and on that how the design of the vehicle matures. So this is a completed development phase. Once you develop the phase, then most important phase come as a confirmation. So what is requirement we have given, the way you develop this product, and how it is confirming. This is a very called as engineering sign off for the NVH targets. So that always very important in the confirmation phase. And it always oftenly happens, whatever we signed off here as a confirmation that what we set in the requirement and development phase, the most challenging comes as a pre-series. Because when the SOP start of production, so every part or every aggregate, every systems are started operating in the tolerance bands of being provided by the designers. And there's every possibility that when we start the pre-series and going for the evaluation of the NVH attribute, you will fall either your NVH performance goes here, or maybe just starting of the development. So almost 3 to 4 dB noise further increases. It's a very normal phenomena. But anyways, development is happens with 3 important ways. One is the part, second one is the design, and third one is the process. So all three are important pillars of it. The part being supplied by the either made in house with by the OEMs or with the suppliers. Design is engineering done by the engineers, engineering R&D center, and the process, which is a manufacturing line. So all three are equally contributing to mature the product and mature the process here. You may have to take the last minute also corrections into the process, corrections in the design to stick to the performance which we have confirmed or which we have signed off during the requirement phase. So all phases are equally important for us. Now into going to the more detailing. So that is how concepts is phase 1, detailing is a phase 2, validation is a phase 3, and start of production. So this is we can go into the more detailed of it, very top level been shown. But every aggregate, every component plays a significant role when we do the conceptualization. Then detailing design, validation, simulation, similarly validations. When we go into the product prototypes been ready. So this is this plan, if you can look at, it will be more than 300 line items where we can write very in detail how this BEV or NVH development methodology has been happens. Now coming this model, which is very important, it's not only for NVH, it's applicable for everywhere. But NVH being such an important parameter because all bumper to bumper, every component, even nuts and bolts are also going to play a very vital role. Even torque what we are applying, that is also going to play a very vital role. So this is very important. What is the voice of customer? What people are talking about this product? What is the customers are looking for this product? OEM always go for the voice of customers of their previous generation products. Or if there is a startups, they can always look at which segment they are operating, going to operate their product. And then they can look at what is the verbatim of the customers about that segment of the product. And then that becomes the voice of customer, and you can define the product what I want it. Then level 1 is the benchmarking lesson learned from the that is called as vehicle technical specifications. So for NVH, this vehicle technical specs goes to 1,000 line items total, more than 1,000. Then subsystem level, like powertrain mounting system, then EDU system, battery system, body, doors, cross car beam, steering systems, all subsystems. So that is called subsystem technical specs. And then next comes the component. These are the systems and subsystems. But if you drop down further and look at that, there is each one is a component which is making this system or subsystem. So when we are looking at it, we as an engineer has to write down very specific requirements till the component level. And that is the phase of cascading. And then once you do this, the design maturation and process happens, parts comes in, and then you go for another side is that is you are in the validation phase now. This is the design and development phase, then you go into the validation phase. So it will be a component test report, system level test report, vehicle level test reports, and validated product. So this cycle is not only applicable for NVH, but it's a generic cycle any automotive engineer follows for the development of the vehicle. Yeah. Yeah. So if you can look at how the now coming back to the NVH domain. So how NVH expert work here? So NVH expert is actually integrator. He is an integrator, and so I'm seeing that there are people are raising the hand. So I can request because if you can park your questions maybe at the end of the session. Let me finish quickly. So there will be more questions, or you may find answers in the subsequent slides. So my request is that please hold for some time. So let me finish the presentation. Yeah. So there are the component experts, there are system experts. So in electrification, that's e-motor, inverter, transmission, entire control strategy. And then that integrated as a called as EDU, electric drive unit. That is one system, and that this is a system. This system plus battery becomes the entire electrification system. And top hat, which is already conventionally we are developing, so that sits on it. So again, there will be another vehicle sides comes up, that is the integration experts. So like mounting system, then subframe, chassis, that suspensions, brakes, steering system, and the body system. So all this put together. So we look at the system and component level, NVH analysis or NVH requirements, vehicle and integration level analysis. And NVH expert actually becomes the integrator of this entire bumper to bumper. From this bumper, front bumper to rear bumper, all the aggregates are sitting in this, and that is how NVH expert has to have a skill sets and mindset of the as an integrator of all these aggregates, and then look at NVH as a attribute which customer is going to pursue into going into the details which cascading I have shown. So in up to that level of the details. Now, why the target setting is important? It's a very important slide. One of the example is interior noise level. When you are looking at the interior noise level, there is a component level noise level. There will be a transfer path associated with that. And then that transfer path, either it is an airborne transfer path or structure-borne transfer path. And then that together can give the complete noise of the vehicle. So the target cascading, the way we do it on the aggregate level, similarly the cascading of the noise associated also to be done with respect to is it airborne noise or is it the phenomena of the noise which is occurring or the transfer path which is giving it. So it is also important in terms of the noise signature associated for us. Okay. Now coming to e-powertrain NVH development. So what is e-powertrain basically? So in India, there are still people are working. There is none of the car is like directly like a EDU. There are motor, torque converter, inverter, all coming differently. Or motor and inverter is one case, and then torque converter transmission is getting connected to this. EDU is a complete unit where motor, gearbox, or torque converter or inverter are in the same assembly or same housing. That is called as electric drive unit, and which is a very smaller in size compared to if you assemble three different things: motor, torque converter and inverter. So that becomes larger volume wise. So this is always the best solution so that it occupies less space in the powertrain compartment. So this is the, when you are looking at it, am I getting a EDU or I am getting a 3-4 different aggregates, where I have to look at the NVH development approach. Okay. Now, when we are looking at it, so concept, when we are conceptualizing in the entire vehicle, so first we are looking at the architecture. So this is complete vehicle level architecture. So how I am going to package the EDU, is a front wheel drive or rear wheel drive or all wheel drive, or only depending upon how we are configuring, how the battery been placed, how the FAW, RAW been designed based on the battery placement. Then what are the different kind of gear or gear planetary sets we are looking at it, lay shaft or coaxial design. So all these are the very concept level discussions where we can finalize. That is what is called as system level requirements. When system level requirements helps you to conceptualize this aggregate into the vehicle. Then we go for the individual as a e-motor development. So where there will be how the base layout between the parameter studies, electromagnetic noise, force excitations, then structural housing and all. Similarly for the transmission, like macro and micro geometry designs, because transmission is going to play a very, very vital role. Unfortunately, in electric vehicle, the whine is becomes very dominant. It is electromagnetic induced voice through the motor as well as the transmission induced voice whine. So both are very difficult to identify as a customer. But NVH engineer can very systematically follow the approach with respect to these two aggregates and come to a level where we can have this: is it a motor induced, is it transmission induced, or it's a housing induced. So this is the concept, overall concept, and we can look at the development. When we design the e-motor, so when design of the e-motor happens with the, forget about NVH concept, how it has been designed. So design specification been frozen based on the power and torque and RPM requirements. Then electromagnetic forces, torque and flux density been defined for this. Then power and efficiency maps are very, very important. Then once that has been conceptualized, then magnetic force analysis, which is creating the mechanical force excitation, which is going to the chassis or maybe long members of the vehicle. And then evaluation of the losses. Because of this electromagnet, there will be losses also. What is the targeted performance? That will certainly have losses. The way we can have the efficiencies in IC engine. Similarly, the motor also has certain efficiency. 85%, 88%, 90%. They're all depending upon how we are developing this entire electromagnetic or design specification of the motor. Then once we do that, now NVH analysis will start. So what is, when we are looking at electromagnetic, phase unbalances, slot openings, the magnetostrictive expansion of core lamination. They're all the design terminologies being used for the motor design. Okay, and what are their dynamic stiffness with respect to that also we have to look at where I have to optimize. These are all design cycle being start actually for the overall motor development. The mechanical like assembly issues or bearings which are being put up on the shaft, where which has been transmission shaft, or windage, complete winding what we are looking at on the vehicles. So that also creates the broadband noise. So this is mostly, these are the sources, very typical sources. In NVH, 99% is a root cause analysis and 1% is solution. And that is a very tricky, that how to identify the root cause. So these are the typical root causes and how it is being pursued in the vehicle, which is very important when we do the complete development cycles. Similarly, for the transmission, like concept design, completely micro geometry, then detailed design, micro geometry for this. Then because in transmission, it's very important for the typical automotive application IC engines, we can always go with the DIN quality of 7 or 8 as a gear. But here in this electric vehicle, always 5 or 6 DIN quality is required. So the micro geometries are very, very important, and that also impacting the dynamic forces which are coming on the tooth. So when we're looking at the 5 as a din quality, because very precision gears bit has to be made, because there is no masking. So you are only going to hear the gear whine. So this design process and entire analysis, tooth optimization pattern, and then because of the dynamic forces, the forces coming on the bearing, and that is actually getting transferring to the housing. So it is very important how we are defining this. So one of the dynamic analysis of gears for tip relief. Sometimes the tip relief has to be given so that smooth engagement and disengagement happens. But that time there is every possibility that the torque transmission, which we are looking at efficiency close to 99%. So that will be getting impacted. So when we are giving tip relief, but there is an impact on the transmission efficiency. So such parameters has to be designed in the detailed design has to be considered. Also, NVH angle has to be given for this. Then detailed structure bone noise. This has been motor we have seen, then we have seen transmission, but housing, because all these shafts are coming out of this, which is rotating and given to the transaxle and wheel centers. So these shafts are, this is a housing. This housing is having its own characteristics, that is called as modal characteristics. It's having its own natural frequency, its own modal shape, and then damping characteristics of the material which we have used for housing. So that was another challenge, the excitation forces coming out of the electromagnetic forces and plus the dynamic forces which are coming from the transmission. So that getting transferred to the housing. And then housing it's having its own resonances. Those forces also getting multiplied because of the resonance and giving to the attachment points which are mounted on the long members or maybe subframe at the vehicle level. So this is overall powertrain and NVH development. So we have to look at the powertrain being a very important source into electric vehicles. So it's in fact it's not only, it's all the vehicles, but now we replaced the broadband source as IC engine, and then we put up the very silent and very peculiar noise and vibration characteristics as an e-powertrain. So that is having its own challenges, because in electric vehicle there is always IC engine, there is always masking. For one of the other noise will be masked by either powertrain, either exhaust, either intake noise or wind noise. A lot of masking was there. So you may not, and you as a consumer or as a customer or as a driver, you always used to have a specific signatures of the noise in IC engine. But especially in EV, so there is only whines, or some of the, if anything really something goes wrong into the design itself, then there will be structural excitations are also coming. So e-powertrain is very, very important, low noise, but having the significant impact on the sound quality and acceptance of the vehicle. Once we did, now we are entering into the vehicle level development. So when we have developed the powertrain, now entering into the vehicle, there are four important aspects. One is complete BIW design, body design. The acoustic package is going to play a very, very significant role into electric vehicle, as because this is having all high frequency noises. An acoustic pack or sound pack is having that strength to control or to attenuate the high frequency noises. Then road and wind noise, because all other noises are not there present. So these are becoming very, very dominating compared to IC engines, and they are significantly contributing into the overall perception of the vehicle. Then next one is the cabin refinement. In the cabin refinement, if you can look at, there are many sensors, there are many motors being placed into the vehicle, as India is now moving towards the ADAS 2.5. So many of you are aware that so many vehicles loaded with so many features. When those features are coming up, there is always a mechanism, there is always electrical, electronics. So all these are very, very much loaded into the vehicle, and they are having their own dynamics and they are having own their noise characteristics. So auxiliary and mechatronic noises that makes the cabin should not, that the cabin refinement be influenced by all these aggregates. Okay. So now coming to the BIW. So BIW is actually a really innocent in this, because it is a response. It is receiving the response electron as a BIW. They don't have any own excitation. Either they get excitation, BIW get excitations from the road induced or powertrain induced. But this is very important when we conceptualizing, is it a front wheel drive, is it a rear wheel drive or all wheel drive. So drivetrains are playing a very significant role, and some of the vehicles, and now it has been banned, maybe there are hybrids are coming up, but some of the vehicles are now having range extenders. There are small IC engines being placed single cylinders, and then they are charging the battery continuously. That is called as range extender. But India, range extender concept has not been launched. None of the OEM has been launched in India. But Europe market, it was popular for some extent. But now all people have now migrated for either for ICE hybrid, or maybe an electrification. So, but the drivetrain plays a significant role here. Then electric drive unit, basically. So what is the characteristics? It's high order noise, as I told you. It's airborne as well as structure borne. And the concept, how we are mounting this, it is not like conventional IC engine. So we have to ensure that when we are having mounting it, so there is the advantage of rubber agri components or isolators. You are going to give higher stiffnesses from the durability point of view, or from the way they are carrying the weight on overall vehicle. So we always often giving the higher stiffness of the all isolators. Okay. Then suspensions. So because this entire weight, if you can look at typically FAW, RAW is always, if it is a front wheel drive, it is a 65-35 or 60-40. But many of the OEMs are ensuring that it should be 50-50 or maybe 48-52, but close to 50-50%. So it is having its own challenges now to have the stiffnesses, dynamic characteristics, or the damping characteristics of the suspension elements. That is having it is always a stiffer than compared to IC engines. And then battery and electric subsystem. So there is a concept. As of now, we are in the two-wheeler, we are assembling the battery. But there are a couple of two-wheeler manufacturers have made integrated battery housing with respect to chassis. So there is one chassis. I don't want to take the name of any OEM here. I don't want to give. But there are a couple of two-wheelers. They are having battery along with the chassis, integrated battery and chassis. But especially in four-wheelers, it is a hybrid, partially integrated, bolt on with effect on belt. Some of the brackets are coming from the body, which are the battery bracket, and some of the brackets are coming from the battery. And then it is a hybrid, partially integrated bolt with effect, and that having a significant impact on the body. So there is every chance that the body's torsional stiffness is reducing. Okay. Then first is the fully integrated. This concept is in India or maybe globally people are evolving. Means the floor becomes the battery housing. So the people are working on it now, cell to pack directly. The cell has to be assembled into the vehicle underbody itself. The people are working upon the safety aspects of it, or the crash regulation aspects of it. But this purely bolt-on part or partially bolt-on part is very, very much available in the marketplace right now. But the best is to have a fully integrated, because it gives a lot of advantages in terms of the lower order modes of the overall body and as a vehicle. So you can give higher torsional stiffness, higher dynamic bending stiffness, so which is pushing and giving the solidity to the vehicle, so that the excitations which are coming up, they are not having the higher response compared to partially integrated or pure on-bolt part of the vehicle. So the way battery we mount, okay. So there is a noise transfer function behavior and the acceleration, excitations coming from this. So these two are how we are mounting the battery, and I already explained it. So there are very specific requirements. So there must be a 14 attachment points, the battery being, because on the battery there will be a high voltage components are also running around. There is a battery management system, the EDU, there are converters, DC-DC converter, AC-DC converter. So all are mounted on near to the firewall or on the battery housing, and they are having its own excitation. So how much we should have the noise transfer functions, and how much we should have the vibration transfer function. So that is having another definitions for electric vehicle compared to IC engines for the noise transfer functions. Okay. Now testing based approach now. So this is we have defined the body. Now coming back to the overall, how when we integrated body into the vehicle, or as a vehicle as a body and plus powertrain integration, there are two ways: the airborne transfer and the structure borne transfer. So the airborne means whatever you are hearing here, so that noise directly entering into the vehicle. So firewall becomes your isolator from the noise, attenuator from noise point of view, but still you are going to able to hear that noise. So that is called an airborne noise. Other one is structure bone, because these mounts are sitting on the long members. The isolation efficiency of the mount plays a vital role. So all the excitations, because of the transmission, because of the motor, that is getting transferred to the long member, and then long member attachment stiffnesses. So that also plays a vital role here. So how much dynamic stiffness we would like to keep, and based on that, the multiplication of stiffness and isolation efficiency and the force noise, the NTF, noise transfer function. So we can find out the how much noise is entering into the vehicle. Okay. Same way, vibroacoustic charge. This is one of the ways vibroacoustics is a excitation being given and how much noise is getting generated to the speakers or maybe these. And one is only purely vibration transfer functions. Okay. So NTF, VTF, ATF, these are the very typical terminologies when we are looking at it during the body design. So all these entire BIW, sheet metal parts, as well as the transfer parts like the local structure plus isolators and the source all come together and define the interior noise characteristics of it. Okay. Now coming to the encapsulation. So encapsulation, so there are four kinds of noise, like basically EDU noise, mechatronic noise, road noise, and wind noise. Okay. So reduced absolute noise levels. If you can look at IC engine at the initial phase, almost there is a 10 dB difference between the IC engine and the EDU noise at the powertrain to powertrain level. So what happens in IC engine itself, there is a lot of masking is coming up for the different noise levels. But in EDU, there is very low noise level, so you can clearly hear other noises also. And main excitation frequencies goes into the higher frequency side. Okay, so and we in IC engine we used to provide a lot of thermal treatments all across the firewalls. But here there is no need, because there is no temperatures are not like as high as 150 degrees centigrade or 250 degrees centigrade at the catcon location and all. So there are a lot of treatment we can get away and reduce the cost. But that is also having disadvantage for EV, that then we are removing those treatments, but they are also acting as a noise barriers. So this is one of the challenge here. Mechatronic noise, which is, as I said, there are a number of motors are in the vehicles for different operating mechanism. They are having their audible noises. So that also getting heard in the outside. Some of the aggregates put up outside, some of the inside the vehicle, like in the motor winding, so window winding motors. So that you can clearly hear now. Because earlier there was a lot of icy, nice noise was there, so that was masking. So you can have a small whine of the window winding motor, one of the example I am giving. Then wiper motor noise, that also you are going to hear. So they are all mechatronic noise. Then road and induced noise, because here road induced noise, it's always been a dominating in IC engine, sorry, in EV. In IC engine, ICE as well as the road induced, both are more or less same frequency ranges. So as a consumer, we always feel it's a engine noise. It's very difficult to for normal consumer to identify the difference between road and wind noise. But here there is no low frequency noise in EVs. So you can very much getting irritations, or maybe you can clearly point out that there is a higher road noise then. And same thing for wind noise as well. So wind noise typically starts from 1000 hertz onwards, very high frequency, and being a very flat torque curve for the motors, the drivability of these electric vehicles are significantly better than the IC engines. So you are tempting on going on higher speed drives. So high speed drives means you are going to have a higher wind noises on this. Okay. So measures are like typically measures lightweight absorption material and make the decoupling or underbody shields and all this. Now people have started developing this. Now in India, electric vehicle revolution started actually post-COVID basically. Till that time, there are a lot of debates from the market sentiments, from the government policies and all. But now you might have you are seeing now many players are entering into electric vehicles. 2026, there will be 40 models will be available all across India in the electric vehicle segment, starting from hatch to the SUVs. And that time, this kind of acoustic treatments people are going to use, and OEMs are going to use to control the noise and vibrations for the vehicles to improve NVH performance. Yes, as I said, the acoustic package is always been very influenced. So this is a package when there is a when there is no noise, no acoustic package. This is a noise level. When there is an acoustic package, this is noise level. And there is a leakage. Even if you provide the acoustic package, but there is a leakage in the system, so all noise can be heard, then the noise level significantly increases. So to avoid the leakage or flanking transmission, that is equally important. In IC engine, it was always been masked, but in EVs, it is not been accepted that there is some leakage and that gives some sort of whistling or some sort of noise which is entering to the small ones. So that will deteriorate the NVH performance. Also, when we are looking at the interior sound quality, we should always look at whatever the trims which we are using all across, coming from the firewall interior to the roof, for the floor, underboard floor panels plus seats, then roof liners and all. So they are also going to play a very vital role, because the road noise right now, there is excitation is only from the road, which is becoming very dominant, and there is every possibility that the standing wave, which is because of this panel going into the into the excitation and then wave getting generated. So this wave gets reciprocating with each other, this panel and this panel. And now this kind of issues, especially for the road noise, that can create the standing wave phenomena or booming perceptions in the vehicles. So interior trim development from NVH perspective is becoming very paramount important into the electric vehicles. So Chaitanya, please hold for some time. I have seen your hand raised. So please give me some time. Yeah. Now coming to the next is the induced the phenomena induced noise like road noise. So I already explained the contact, then axial loads because of this, then waves. So this is the tire road interaction. So that creates the one of this, and then this is the excitation. Who is the transfer path? All the suspensions attachments, suspension links, then all axles, they become the transfer path for this. If you can look at in the road noise of the gasoline engine, there is a broadband noise phenomena up to 300 hertz, rough road and smooth road. So I can give you the very big good example. In India, there is a lot of concretization is happening even within the cities as well, not only on highways, but even within the cities. There is every tendency that rough road and smooth road. So concrete road been always termed as a rough road because there is no absorption compared to the tar road. So there is always a difference between the smooth road and the rough road noise levels. So if you can look at in this, there is no, there are a lot of frequencies which are also contributing and coming from the powertrain side. But here the powertrain noise is at the minimal. So these are the frequencies which you are seeing. They are all the road induced frequencies. So due to absence of broadband noise which you are seeing into the gasoline engine, because we are comparing only with gasoline, there is no point in comparing with diesel. So many of the companies has already declared worldwide that they will not enter, they will like to stop the diesels maybe from 2025, 2030, 2035. Everybody has raised the mission statements to entering into the EU market. So it is always better to compare with the gasoline and then road industry. So if you can look at this is purely a road excitations, which is being shown in the broadband as a noise signature of it. So as then it is having another challenge is how to reduce this, because you are going to pursue this when you are moving on the smooth road and immediately entered onto the tar road. So this noise level you will pursue that is very loud. The loudness of this will be higher and you will perceive it and you will feel that this vehicle is more noisier on the rough road. But on the similar patch, if you drive this road noise and this, I think that perception is slightly lower compared to the electric vehicles. So we have to give a lot of importance for the road noise development in electric vehicles. Same thing for the wind noise, because there are aerodynamics of the car which is playing very significant role. Fortunately, in electric vehicles, the coefficient of discharge people were targeting in current IC vehicles are around 0.31, 0.32, 0.33 like this. But very flat floor in the electric vehicle, that has given the advantage of 0.2 to 0.3 count improvement in the CD. So when that improvements in the CD is coming up, so that becomes you can very smooth smooth flow, or the if you can look at aerodynamic drags, so all across the vehicle, but then that can looked at as a source for the wind noises. Then second is ceiling issues. So all across the vehicle, these are the where we are applying the ceilings, because now this is look at this is one of the challenge. The least utilized feature in India is sunroof, or moonroof or something like that. Hardly people are using it, maybe once or twice. But every car is now, every manufacturer is giving, even in small car, this feature is giving them. But that is also having challenges because there is a ceiling, lot of ceiling. So wind can enter through and you can hear this. It's another challenge for the NVH engineers. So the ceiling important aspects, and even though in wind noise, even though if you can look at this is gasoline noise again compared to the threshold is 100 kmph. How you are looking at as a wind noise of the vehicle with compared to 80 kmph, it is more or less similar, but you will find a difference here because once you move from 80 kmph to 100 kmph, 100 kmph to 120 kmph, you are clearly feel that you are increasing the vehicle speed, and then wind noise perception will increase. And this is also, I am also user of electric vehicle, so I am perceiving this. I have never drove this vehicle more than 100 kmph, but I clearly perceive that how that perception of wind noise is increasing. Okay? So in gasoline engine, up to 1000 there are many noise sources, so that used to mask some extent with the wind noise. Then coming to the cabin. So as I said, there are many mirrors, foldable mirrors, windows, sunroof, seats, all seats. Now there are 8-way seats are there. There are motors. So all they are going to put up lot of electromagnetic noise. And this is the cabin become absolute silent. Then these noise levels are very smaller, but they are come into the operating sound qualities aspects of the vehicle. And this is a mechatronic noise, basically mechatronic systems noise. So that is going to pose a different challenges for the NVH engineers. As of now in India market, as I'm owning the electric vehicle as a consumer, I would only migrated from ICE to EV. To be honest, many of customers like me or many EV customers, they are not at all looking at these issues as of now. But when the customer base, currently there is only 2% of the volume as of now. Considering the India market, 3.8 million passenger cars, we are only 2% of the vehicles we sold as electric vehicles. So only 2% of the customer. So as of now, there is only migrations they are enjoying from ICE to EV because there are many delayed factors like range, silentness in the cabins, a lot of comfort because there are no gearing system. So it's like automated car and all. But when you used to drive and the customer base is increasing, there will be certainly a critical customers which are going to point out all these sources of the noise. And 2 year or 3 year down the line, when the customer base will increase for the electric vehicles, these are going to become a biggest challenge for the NVH engineers. Okay. Now, this is what the overall NVH. Then coming to the last part of it, we always think that the electric sound vehicle, the sound design aspects of it, because we always think that silence is the better. No, psychologically, you cannot have a dead silence. We always want some response, and that response either in terms of the tactile feel or in response in terms of the audible feel. So the giving the warnings, giving the sounds, specific sounds, when you are giving the accelerations and to the motor or maybe accelerator pedal, we used to get a lot of response from the IC engine. We used to get that, yes, now my engine RPM is increasing, but that kind of response is absent in the electric vehicle. So what we have to do is to create that kind of, instead of the very dead silent environment, instead of audible chimes and the mechatronic noises, but this is a more and more psychologically not accepted. So detrimental, not accepted, negative effect of it. So there are people are designing the active sound systems. Okay, there are many cars. Now I would like to take the name of the clients. So there are Mercedes EQS, then Kia EV6. These people, and our Tesla is always leader in this market leader. More than 1.5 million electric vehicles they sell globally in the passenger cars. So they have given the active sound system, ABS, that's called active sound system. So that active sound system means it gives the feeling that you are actually driving like a car, or you are as a consumer, you are getting every response of the vehicle in terms of the acceleration pedal, which we love as a driver to get that feedback from the powertrain. That is one. Second point is important is once electric vehicle comes, the IC engine we used to get a lot of some noise, some exhaust system or some power drain. So we used to get, but there will be, if the pedestrian safety point of view, in European market there is a AVS, active vehicle alerting systems. So when pedestrian comes to the closer to the vehicle, there will be sensors and a typical sound signature will be generated. And now that is becoming the regulatory framework. In India, as of now, there is no regulation, but the way population from 2% to 5 or 5 to 10% will go, certainly our Indian OEMs also has to give the AVS systems as a regulatory framework. So when we look at the electric vehicle sound design, so these are the psychological effect, sound quality, and then overall warning of the vehicle something. So the brand, and with this sound design, you can always look at the brand exploration can be done. So the way now I will give the example in IC engines. So two-wheelers, every two-wheeler is having different brands. Okay, sound brands in like a Royal Enfield. Many youngsters are riding nowadays on Royal Enfields because they are having typical brand signature. We need not to even look at the vehicle, only by signature we know that this is a which brand. And even in that Royal Enfield there are 3-4 more vehicles categories. We can also know which is that vehicle in the Royal Enfield brand. So in EVs the brand exploration is going on. So people can associate that this is a X OEM's vehicle, this is a Y OEM's vehicle, this is Z OEM's vehicle, and that kind of model we are creating. We as a being an engineering service provider, we are working upon it. We are creating our data bank. We are creating our sound libraries so that that can be transformed into the brand identity and the vehicle feedback systems. When the as a ABS, there will be two different. The brand identity will be different or ABS warning will be different. So you can come up with like a styling, the way people are looking, the way the people like the vehicle based on the styling. The same way people will also differentiate the vehicles based on this branding of based on the sounds. Okay. Yeah. And yes, now this is the most of the our more of our vehicle point of view or FU point of view. So what are the full totally globally we are having 150 NVH experts. So more than 1,000 NVH projects and global, you name the OEM, we are associated with them. In India itself, we have done the 5 dedicated EDU, e-motor NVH programs, and this is basically just to give the glimpses how this experience has come up and then how I am able to deliver this talk to you. And thank you very much for all my colleagues, those who have prepared this presentation for me, and I'm also giving many thanks for all the participants, those are very patiently listened to this. And now over to the question answer session. So those were I was not able to see it, but maybe there is a people have raised the hand. So I will request SA team to please release the microphone so that I would like to listen the questions. Hello.
Hello.
Hello, am I audible?
Yeah, yes, sir. Audible, sir.
Yeah.
Yeah.
It is
Can I go ahead?
Audience. One by one, please ask questions, please.
Yeah. Hello.
Yeah. Yeah, Chaitanya.
Hi, sir. How are you? It's very glad to hear you.
Yeah,
Very
nice to see you again. Yeah, in NVH Women's. Yeah.
so I have not started my video. Yeah, glad to hear your presentation. It's very insightful. I would like to point one question regarding the electric vehicle development. As you know that see, we have some thumb rules, or we have so much experience in ICE engine vehicles, especially for of course for NVH refinement. We know from, as you said, bumper to bumper, we all had good exposure and experience. So my question is related to how will you actually fix the targets and cascade the targets in terms of electric vehicles. For example, as you know, we have some in IC engine based vehicles, we will fix the frequency based on the major primary orders, engine orders, and
Yeah.
we have radiated noise of 90 dB, we have NTF, we have model frequency targets. while actually during vehicle refinement for electric vehicles, what is your thoughts on for radiating noise of motor or whatever EDU you said, or entire powertrain, and as well as how will you tune the other systems to have the, of course we will be having quieter vehicle, but as you mentioned that there will be vines obviously in electric vehicles. So how will you address while actually during your pre-production pre-design itself? So
Yeah.
can you please throw some light on that?
Yeah. So yes, I think this is a. It's not only you, Chaitanya. So many of the NVS fraternity is having such kind of questions because we are completely replacing the one powertrain which we are working since decades. I'll say 100 years in the automotive industry, and all of a sudden we are replacing that. We know the slider crank mechanism. We know the crank train. We know the wall train. We know every aspect of it. Our ancestors has done a lot of work, and then now we are very happy that we used to calculate the forces, and then
Exactly.
the NVH engineer, it was very easy going for us
It
because
was
lot of
given actually.
huh? Sorry.
It was given actually
Yeah,
in
yeah.
ICM.